Good afternoon, everyone. My name is Dolamu. So this afternoon, I'll be convincing you on why you should write code with type annotations. Like it's something I noticed. Like okay, when I started writing like Python, fine, everybody started writing Python because like the language was simple and very easy to understand. But at a point, like what Aisha said in the morning, I came for the language, but I stayed for the community. At a point, I noticed that there was this concept of type annotation. Of course, like I don't know if anybody writes C or Rust here. Like those languages, you notice that if you write those languages, like if you are writing, if you want to write a data type, you have to like put. I mean, you want to like them define a variable. You have to like define. You have to put like the data type after the variable. But Python is not like that because Python is a dynamically typed language. So like I'll just be like talking about that this afternoon. So first of all, okay. I don't know if you guys want to know me, but it's fine. Like I'll just talk about like what I came here for. So like I'll say why type annotations. So like I watched an interview about Van Rossum is the founder of Python. So he talked about type annotations, like type hints in Python, and he stated that it is something that just came into existence and is not going to be forced because Python was created for people that want to like learn a language that is simple. And he said when writing, like the main reasons why I feel that we should use type annotations because like when you write programs, I don't know, you have like two audiences to be factual. You have two audiences at once. Your computer needs to understand what you are writing. When you write a code, like the computer converts the code to ones and zeros. You need to understand what you are writing. And at the same time, the code has to be readable by other people. Like you write a code now, you put it up there. Like it's not only for you. You're writing a code so that other people can understand it. Let's say you write a code that extracts even numbers from a set of numbers. Of course, you understand it, but I'm a stranger and I see that code online. You are writing it because you want people to understand it also, not just for yourself. So at the same time, you're writing codes, the computer should be able to understand what you are trying to do. And at the same time, I, as a fellow like programmer, should also understand the code whenever I like set my eyes on it. So what are type annotations? So it's not a big deal really. They are just, like I said, if anybody has come across other languages like C, low-level languages like C, Rust, and the likes, you notice that like when you are defining, for example, you are defining an integer. Let me say in Rust now, like Rust, when you define like let's say number equals to 2, the number has to have the data type at the back of like that variable to show that anybody reading the code that okay, like number is a variable. Yes, I know, but what type of data type is number? Is it an integer or a string? I don't know if you get. So in a way, like the computer understands that okay, number is an integer, and when you are trying to like use that variable, like okay, for example, integers have like attributes or method, or let me say strings in Python. When you define a string, it has like methods. For example, you can make, if the string was a capital letter, it has a method lower dot lower like open bracket. You can use to like make the string like lowercase. So defining that variable as a string, automatically your IDE will streamline methods that variable is accustomed to just for strings. So it's get rid of like order. If I don't define the variable, it should not know that okay, this variable is this particular data type. So you'll be exposed to every like the methods for integers, strings, and also like in a way you're helping like your IDE, and you're also helping like other people to understand the code you're writing. So type annotations are just simply intents that give you an idea of what a variable is. Simple like I said, like you define a variable and I put like the data type at the back. Anybody that comes to like read the code knows that okay, number is a variable, and because I put the data type integer at the back, of course, it's going to be holding an integer. If anybody equates it to a string, you know it's a mistake, or you know it's wrong. So like I said, type annotations are simply intents that give you an idea of what the variable is. and type annotations are optional but compulsory for readable and durable codes. That's like a paradox, because you want to ask yourself, why is something optional and compulsory? I don't know if that makes sense. Something optional, you're saying it's compulsory. Why? Does it not make sense in a way? Okay, it's optional because even when Python is, like I said, is the dynamically like types language, like, which means that like the types are checked when like you run the when you run the code. So even if you don't define the data types when you write the code, your program will still run. That's why it's optional. Your program will still run with or without typing things. Your program will still run. It's just a way of making like your codes readable to the computer and to other people that are reading your codes. And it's compulsory because you want to make your codes readable. So it's optional and compulsory at the same time. Like that's a paradox actually. Something cannot be optional and compulsory. So it's optional because like I said, it's optional because when you define, if you are writing the code without defining data types, your code will still run with or without the typing things attached to the variables you define. And it's compulsory because, of course, you don't want to be selfish. Like you wrote the code, you understand it, but what about other people that are reading the code? Like you don't want to be selfish and just only you understand what you wrote. For example, there are codes that are on GitHub now, and they are open source codes. Someone wrote the code and it's open source. The person did not write it just for himself. It's for a community. So he wrote that code. You are trying to make it readable for other people, and also like for other people, easier for other people to read the code also. So it was this concept of type annotation was introduced in Python 3.5. Actually, it was not in existence before because Python was created to be a very simple and readable language. So like I knew that when people see languages like C, you're always very scared because of the way the syntax is. Like you're saying variable like those, you're saying int, like you'd be like, what is this? But you came to Python and you were like, number equals to 2. It was very simple. That was why you came, like that was why most of us, I can say that's why most of us like stuck to like learning Python. So in a way it's not compulsory because like of course that was why the language was made for everybody, for it to be simple to understand for everyone. But at a point you have to consider readability of the like what you're writing to for other people. So it was introduced in Python 3.5, which means that like after Python 3.5, you could actually use type annotations with your codes. And I think it has a module typings like where you can actually, you have to like, some of the typings are not available in this particular, any version lower than 3.5. So you have to use a module to import the typings to your code. For example, I think like the typing list was not available like in Python 3.5 or 3.4, but there's a typing module where you can actually import lists to your code. Then you can annotate like that data structure with the that particular typings. So okay, like if you are going to be very familiar with type annotations, you have to be very you have to know data types very well in that language, a particular language. There's no language that every language from C, Rust, Python, JavaScript, you have to be very conversant with data types. That what makes up the language. Any variable is a data type, but you need to know what that data type is. Is it an integer? Is it a float? Is it a string? Is it a boolean? You need to know what that data type. So I said like data types are very fundamental and generated to programming languages, and they define the kind of data that can be stored and manipulated in a program. So in Python, we have integers. Of course, they are all numbers. Integers are all numbers. We have floats, we have strings, and we have booleans. So these various data types, they have like their respective type ints. For integers, int, int. For float is float. For string is str. I don't know if you might be familiar with that. Then for boolean is bool. I didn't write that here. So I'm sure we have conversant with data types in Python. Is there anyone that's not conversant with data types in Python? So you also have data structures too. Of course, when you write codes, you have to manipulate data structures from lists, tuples, dictionaries, and sets. And this, like I said, type annotations was introduced in Python 3.5. So any version after 3.5, you have to, okay, they're actually available, but any version lower than 3.5, you have to like get the typings module and import these data types into your code. So like I said, you have to be conversant with data types if you are going to use type annotations. And I have like a code example here. And I'm sure, I don't know if anybody has experienced some, you wrote the code yourself. You wrote the code yourself, fine, today. And you came back after like 2 months. And you're struggling to understand what you wrote yourself. Like, I don't know, I don't know if I'm the only one that's experienced that. If you have experienced, can you just raise up your hand, please? So like, that's one of the essence of like using type annotations to your code. Like, you don't want to write a code today and you come back in, even after 2 weeks, and you're like struggling, what is happening here? Like, what is, what variable is this? What, like, it happens to a lot of us, and I feel like a way to like avoid that problem is using type annotations. If you wrote a code today and you annotated like the variables, of course, when you come back to the code, you might not understand like immediately, but the type annotations will help you like in a way to make understanding it easier compared to when they were not there. Okay, you come to the function and you see like, okay, you defined an argument, numbers, and you annotated it that, of course, numbers can be any data type. You get, but when you come back and you see numbers and you annotated as an integer, you know that obviously it's an integer, and you'll be able to like decipher what that variable is doing in the function. I don't know if you get that. So I have like a code sample here. So like this is this is like a function that I don't know if anyone is familiar with Lon's algorithm. It's like an algorithm for verifying SIM card numbers. So this is just like a simple Python function. So you can see like this function I wrote, like this is the function I defined. There's an argument numbers inside the function. There's another function inside that function. This is digits of. So I'm trying to convert. So I feed another variable into digits of. Then I'm returning. Of course, I'm now using a list comprehension to like return integers. You cannot understand, like, of course, looking at, if I wrote this code now, if I come back to this code like in the next 3 months, I'll be struggling to understand what I did here, because is numbers a string? Is there an integer? Like, I'll be asking myself that question. And I might just have to, fine, because I'm now using a list comprehension here, I know that this thing is an iterable, so it cannot be an integer. It has to be a string, a list, or any other iterable that you can iterate to. Because you cannot iterate to an integer or a float or any number, whatsoever. So this is just like a code sample of a code that does not have like type intings. I'm sure we're all struggling to understand what's happening here, because there are no type intings in the code. Even I myself, because I wrote the code and I did not annotate the arguments or the arguments in the functions. If I come back to the code in the next 2 months, I might be struggling to understand what I wrote here. So like I have like I actually have like there are 3 different ways you can actually annotate. Like you can use doc strings, and you can use like type ins, and it's either you don't put type intings at all. So this is the first sample. Like there are no type intings in this code for this particular example. Then the next one is I use doc strings here. So okay, yeah, fine. I put documentation in my code. So you can say I wrote, check that's the definition of the algorithm. Check that the provided number passes the long check algorithm. So like you can check that link to understand what the long check algorithm does. So you can see I define my parameter number as a string. A number represented as a string. Then I define what it returns. It's meant to return a boolean true. If the long check is correct, it returns true. So you can see here like, okay, yeah, if you are looking at this particular one now, you can still understand a bit what the code is doing, because I know what the data types are, the arguments. Okay, fine, you know that the numbers now is a string now, and you seeing this list comprehension here might not be surprised, because of course you can iterate to a string. So from there you can easily read the other lines of the code and like try to flow with what's happening in the code. And this is like the example. The problem with this is that, okay, fine, it is in a way it helps readability, but it's verbose. Like it's too worded. You can see how long the code is. I have to read the documentation and also like try to understand what's happening in the code. And the last example, which is what I'm advocating for, is type ins. So you can see like this is quite understandable in a way. I defined my function and you can see my parameter numbers are attached like the type in string into the function. And I know that it's meant to return a boolean. I want to forget. So like me, if you are seeing, of course, if you are seeing inside the digits of function, you are seeing that I'm using a list comprehension. It makes sense because a string is you can iterate to a string, and you can see like in the second function, I also like returned. I also like annotated what's returning, like a list of integers. If you look at what the first function is returning, you can see it's for d in nr. Nr is actually is a string, right? So you are trying to loop through that string to get the integer form of each of those. They are numbers, but they are in string format. So as you are doing int d for d in nr, you are getting the integers format of that string and it's putting in a list. So you are going to have a list of integers according to what that's like annotated as the output in this digital function. So from there, you can easily understand what the code is doing. And if I'm trying to call my function here, def main, so you can see like the argument I provided here is a string of numbers, like a string, but these numbers, it makes sense, right? So the first print statement I'm writing there is actually, that's how I meant to like feed it. If I feed it with the second, this one is actually correct because fine, it's a string according to what I defined there, and the code is going to iterate to that string and get the integer form of those strings, like as numbers, fine. Then if I try to like call my function with this now, of course, like I'm using an integer here is wrong because I stated initially that it's meant to be a string. So even the ID, if your linter is working on your ID, it would automatically flag that argument to make you know that, okay, like you are doing something wrong. I don't know if you understand. So I'm meant to feed a string, but I'm feeding an integer. You can make, nobody's above mistake. You can make a mistake, of course, and the ID would automatically just tell you that, okay, fine. It will even allow you, which I use in my system, it will allow you that this what you are providing here is an integer, but you are meant to provide a string. So automatically, like it saves your time. Sometimes you are making these mistakes and you are trying to like look for where you are making errors, but immediately like, you are seeing like the alert that, okay, fine, we are actually on track, but you are providing an integer instead of a string. I want to forget. So like this is like one of the pros of using like type annotations when you are writing codes. And for anybody that comes to like read this code, can understand like what maybe I'm trying. I might not need to be there to explain to the person, but the person is saying that, okay, I'm putting in a variable that is a string inside the function. So obviously, you won't be surprised seeing that I'm returning a list or iterating to that string, because of course the string is an iterable and you can iterate to it, and the rest is actually readable. The rest of the code downwards is readable because you know the data types of each of the variables that are inside the function. So you won't have any issues reading the code. I don't know if that's clear. So like, okay, fine, we know what type annotations are. So what are the tools for type annotations? Like I said, of course, you need to have like your ID, VS Code, or whatever ID you choose to use. And you need to have a proper understanding of data types, from the fundamental data types, integers, string, float, data structures, sets, lists, dictionaries. You need to know, okay, like you want to use a data structure. I know the dictionary. Okay, fine. How do I annotate it? How do I like use it? Or what are the methods that like that this data structure can actually carry out? You need to have an understanding of each of the data structures and data types and what they can do for it to be good with type intents as a concept. And also, like I said, type annotations was introduced in Python 3.5. So for any version, if you're using any version of Python lesser than 3.5, you might have to use the typings modules because some of those typings are not available in that particular version. So you need like the typing is a modules in Python. You can check on it. You can check like the modules online. It's a module in Python where like all the data structure types are in, like they are in that module. So you are just exporting the class. You are exporting them to use in your own code. And again, like I said, I stated initially that like type intents, they are optional and compulsory at the same time. In the sense that you can actually write a code, even when you annotate your codes, sometimes they are wrong, but it will not stop your code from working logically. Like whatever you wrote logically would still work. So you need to like carry out like static type checking with MyPy. MyPy is also an external module too, a Python module that you use to check if your typings in your codes are correct. So like the pros and cons of typing is number one. Like typing is, of course, like I said, it improves code readability and it makes your debugging skills easier. Instead of spending like 2 days debugging a code, you can easily like find out what's happening on your code. And again, it enhances your IDE. Like I said initially, you define an integer, a variable as an integer. And you want to, for example, you want to like define a method to that data type. It cannot be giving you .lower because it knows that it's an integer, not a string. Do you get? So it's actually aiding your IDE to streamline like the methods that are available to that particular data type. And it also has like its cons too, of course. Like increased maintenance of IDE in the sense that, okay, fine, I wrote a code initially, a very large code base, and I need to like change like my data structure and maybe a functionality. I also need to like change my typing, so which is actually like a bit stressful. And lastly, like potential for over-engineering. This one, like when you are very good at typing, you have like this urge. Like there are some variables that you really don't need to like type, like annotate. But you'll be like, I need to like annotate. You start annotating everything in your code, and it might actually be a bit, it might not be comfortable, like might be somehow like over-engineering like your codes. So what next with everything that we've heard here? So like when I was making my study on this, I found out that like about 20% of codes on Python codes on GitHub, they are not annotated. So of course, like it's an opportunity for you to like venture into open source if you want to. You can easily like just look up a Python code on GitHub, and any code that is not, you need to first understand what type annotation, how they work first. From there, you can venture into open source. You can even make a living out of itself. You can get look for codes on GitHub that you can look for large code bases, like very serious codes that are not annotated, and you try to like annotate the code. You never know, the maintainer can accept your code, like can even start implementing them type annotations into like their code base because you did so. So I just feel that is it's actually like an opportunity that everybody should look into, because I noticed that like most of our communities in Nigeria, yeah, we do not annotate our codes. And I saw some guys writing codes that I presented this morning and yesterday. Some actually did, some did not. So it's something that is not actually like common, or we've not imbibed as a culture into communities. So I feel that going forward, it's something we will need to like imbibe, because we are not doing it for ourselves, it's for a community. And you want to understand, you want to put up a code, or you want to write something out there, you want me to understand, or you want other people to understand, you want people that are starting out learning Python to understand too. So at a point, even though it's like looking that it's optional and it's not, at a point we will need to start doing it, because it will be helpful to us as a community and help us grow together. So I think that's all. Thank you very much for listening. I don't know if anybody has any questions. Yeah.